In this video, we will see how to use the advanced parameters like hypertuning of the parameters to improve the model performance. Now you have a model and you have you have done the EDA and everything. Now you have a model which is giving low score. So how can you improve that? So before I dive into this, I want to give you a brief step of how to achieve this performance. The first step is to find the list of parameters for the model. So what model you are choosing, you have to find the list of parameters that you want to queue. Now, before I proceed, I want to say you that there is a difference between parameters and hyperparameters. The parameters, these are the implicit parameters, like the parameters that is used to in the prediction process that has come from the training of the trained data, and which can also be applied to the test data. But in some cases, these things are not sufficient. So in that case, what we could do is we could use some external parameters that is subjective to the model that we are using, and we can change the parameters values and use it. You feed it to the model to get the best performance, so that the target variable would be predicted more accurately. Now, about the list of the parameters, I have put that in the description box, the list of various hyperparameters for various models. So you can check that out. You can also find a lot more about that in internet. I'll put some links also. Now, next method is that we have to, for the implementation of the process, there are various methods. There are grid search, there is random search, there is manual search. So you have to select what kind of search you want to. What you want to search is the best values of the parameters that you want to fine tune with. So that is the list of the that is the way you have to parameters. Now the next is applying cross-validation and access the model score against the unseen data and the trained data. Unseen data, these are the test data. Now cross-validations, when you're using this library like sklearn, the cross-validation comes happening inside that when we're using the functions, the grid search and everything. But when we are doing manually, you are taking the value, you're getting the parameters, you're putting the values, we're fitting the model, and then you're checking the scores. This is the manual process, which is very time consuming. So you have to cross-validate that, so that we want to see the value of the parameters are working fine with both trained and test data, because sometimes it works fine in the trained data because it has been fed to the model and it's been already known by the model, but it does not work in the test data, which is the production data, or you also have a separate test data inside your data set kit. But in case of production, it will not give particular good result if you are not doing the cross validation when you are improving the performance. We are using the KNeighborsClassifier classification model to do the fine tuning, as it is the base model to do the hyperparameter fine tuning. Now you can use this model for regression and classification problems. There are lots of resources available in the internet that you can use to see how this model works and what is the theory behind that. Basically, I'll give you a brief of what is this thing is. Suppose like you have a data set and you feed the data set to this model, and suppose there are green and red data sets, and you want to you give the green data set to the model, and then it will calculate based on the Euclidean distance and the Manhattan distance. There is some internal distance parameters that is it uses internally, so it will use this calculate the n neighbors of the green data point that you give, and it will classify that all the data point that is coming under the distance as green and rest as red, the other classification parameter that you choose. Now be able to do to make this model do the correct segmentation, what you can do is you can optimize the k parameter. The k parameter which calculates uh, the Euclidean and Manhattan distance basically to do the segmentation. So we have to optimize the k parameter. So that is what we are going to do in here. We have to find the k parameters using the grid search methods, the optimal hyperparameters along with that, and then we have to feed it to the model to get the accuracy score k value. So let's get into the code. So here we have this data set. If I run this, we'll be getting this data set. So this data set is standardized and normalized using min, max, scalar, and then it is also log transformed uh, so that these values are uh, a normal distribution. Now we'll define the target variable and the feature variable since we are interested in knowing whether the person is diabetic or not. So outcome will be the target variable and everything else, the outcome will be the, so everything else will be the feature variables to train the model. So here we are using train test split function from sklearn to divide the data into training set and then testing set. Now we'll use classifier KNeighborsClassifier to do the real model fitting and model building. So I'll create an instance of that. I'll fit that xtrain and ytrain values to the instance that is created. So that is done. Now we have imported the accuracy score. Next we'll have to see the accuracy score. But before that we have to use the grid search to get the best params. Like here in case of KNeighborsClassifier, we have to feed one k data as we discussed earlier. We have to feed the k data to get the best results. So in order to get the best k value, we have to use GridSearchCV and we have to give a range of k ranges, that is from range 1 to 31. You can use any values and we have to convert that into a list, and then we have to give the params grid, and these are the values that you can give. Scoring is accuracy. All these are available in the internet. You can find it out so that you will get a grid object. Now using the fit function on the grid object and passing the xtrain and ytrain value, you will get the grid search. Now grid search will have all the params that is required for the optimization of the model. Now we are getting that k-neighbors is 17. Now we'll see the best score. If we are using k-neighbors as 17, so what will be the best score out of the model building? So it is 71%. So and then we'll go to the real model building and accuracy measurement score. So we'll create another instance of KNeighborsClassifier with KNeighbors as 17 because we got 17 over here, and then fit the model and then predict on the unseen data, that is the X test. Now once we do that, we have the accuracy score. We have imported it over here from the sklearn matrix, that is the matrix we want to calculate, and pass the y test data and y test hat data that we got by predicting it on the unseen data, and the accuracy is 72%. So if I run this one, the accuracy is 72%, and if I plot a confusion matrix out of this, we'll get 34 as the correct value. And this is, since we have not done any kind of EDA or pre-processing, we'll get this as a scientific representation. Otherwise these two diagonal values are the correct values, and 19 and 43 are the misinterpreted value. So the next step would be to minimize this false negative and false positive quadrant. So in this video we learned how to use GridSearchCV method to find the grid and k neighbors classifier to get the best value of k so that it could be fit, so that our model accuracy improves. So that is the scope of this video. The next video we will be studying how to understand this confusion matrix and how to manipulate things to improve further. So this is basically the hyperparameters tuning, in which we are using k neighbors as the hyperparameter for the k neighbors classifier. That is the model that we are using. We are also using this is the classification problem, so we are using k neighbors classifier, and the hyperparameters is n neighbors. That is one kind of hyperparameter tuning that we are done here, and we are getting the confusion matrix.